In this issue of Spacecraft Guide, we are continuing to train you on how to be a pilot commanding the space shuttle by teaching you how to fly using the instruments that are on board the spacecraft. And we are going to continue our work in the primary flight display, focusing on this instrument down here, which is the yaw rate indicator. And when you click on it, it takes you to the yaw rate indicator page. You can see that we're focusing on this instrument down here, and it provides a continuous readout of vehicle rotation rates around the yaw axis. Yaw rates are displayed at the bottom side of the pointer. The center mark on the scale next to the pointer represents 0. So this is 0 right here. The graduated marks on either side of the center indicate positive or negative rates. So you see that here. And this is marked at 5 degrees. As we've learned, this can be graduated up to other marks on the instrument, and that has to do with the switches. If you select this is the medium rate, so each one of these ticks is 1 degree. So we have 1, 2, 3, 4, 5, 2 of yaw that's turning along this axis to the left, and 1, 2, 3, 4, 5 going to the right. Now you might see 15 here, and that would be each one of these be multiplied, be 10. 10 would be here, so this would be 2, 4, 6, 8, and then 10. But then when you get really close to docking, and that's within 15 miles, close to 100 feet, this will be switched to 1 by the astronauts to give a very fine indication. So this would be 0.2, 0.4, 0.6, 0.8, and then 1 degree of, and that is rate of rotation. That is not, again, this up here, the error needle for the yaw, this would be 1 degree, where you turn to 1 degree and you hold. This is you turn to a rate of 1 degree per second, because this is 5, so this would be 1 degree per second. And when you hold there, the spacecraft is going to continue to yaw, but it will be at a rate that you want, which is 1 degree. And the reason, again, is for that is with the rate, you don't want it to accelerate too much, then you overshoot your mark. So this is sort of telling you, okay, let's hold the spaceship right here and yaw to the side. So if we go to General, we'll see in the guidance navigation system with the overview that this has to do with the commands, and then the vehicle control with in-flight directory changes are made during powered flight by following the gimbaled engines. So that is when you're powering in atmosphere. During atmospheric flight, these functions are performed deflecting aero services. So that's when you're actually in the atmosphere. Flight control computes and issues of the engine fire and gimbal canards of the aerospace deflection commands. So all of this here is in the atmosphere. So that's just a little bit more information for you in the section of General, which is Guidance, Navigation, and Control. Now, for our Patreon subscribers, that's the paying and the free, which means you don't even have to pay to go with me here. All you have to do is sign up, so you'll get notes when I actually bring something new out or other things. I just put out a special on a manual that was available at a discount for my free subscribers. So what are you waiting for? Join up for free, and if you do, and you're a Patreon subscriber, and you click on schematic, it takes you to the diagram here. And as you can see, this is the roll rate indicator. As you see the rates for the CES, and for that we go to, let's go to the guidance diagram. We're going to go from the board, we're going to come up here, we're going to go to the primary guidance, and you see that this comes into the computer through the control electronics section. So the input is coming in from here, and it's a feedback going into the guidance computer, and then that feedback goes into the coupling data unit, which takes all that information, and the pulse torque assembly, which is going to be important for our paint subscribers when we go into it. So the pulse torque assembly is coming from the guidance computer, coming back into the coupling data unit, the CDU, which is very important because it takes up, it's sort of like the interpreter between what is coming and what's coming in and what's going out from all of the other computers, and then it takes that data and it puts it back out to the guidance computer, and those guidance computer, that goes to the translation commands here, and that goes to the displays. Here we are, the InGen on-off commands into the S&C control assemblies. So all this information is coming into the displays, which are going to tell you what to do on what rate of yaw that you are going to have to hold to either dock with someone, rendezvous radar. Here, this is for the lunar module, so it's only landing on the moon, and then taking off, and then using radar. Now, this would only be for rendezvous radar for the shuttle. That would be coming into like the space or the International Space Station, or a satellite that it would be fixing, or it would be landing, going through the atmosphere, and what degrees that would be on. So for our Patreon subscribers, and these are the ones that the people who pay for this subscription, and we're going to go a little bit further into the schematic. And here is where it's going to get more complicated. And if you pay $4 a month, that's the minimum cost, which, as my wife pointed out, that's less than a cup of coffee at Starbucks. And believe me, I know, I've seen the bill. You will be able to go deep into here. And also, those paying subscribers, they got a free book on the familiarization manual that I will show you later. And if you are a paying subscriber and you click on schematics with me here,